Hi, I'm Guo Cheng Guang, secondary 1 from NS High School. Right now here, we're still going on with our theoretical mechanics. Well, in theoretical mechanics, currently here we are at chapter 1, kinematics. So in this part, what we had last time was this example here. Okay, but this is not actually a specific example, but it's just saying that from the origin point here, you throw something, you make a projection. Well, this can be called a projection, it can be called a projectile. So it's for this part. The initial speed, or the initial velocity here, then you throw it at an angle theta. So you throw it in this direction. But of course, they'll bend afterwards. Well, it's only the path it goes, sort of, you call it bend. Well, in this part, it's just because of the gravitational force that just pulls it down. And for this part of this initial velocity, we separated it into two components. For in the x direction and for in the y direction. So that's what we have in these parts. So in this, we only know this angle that is through and this initial velocity. But then we have to show all of these parts. This first part, time taken to reach the highest point of this projection or this projectile. Second part, the maximum height for this projectile. Then after that, it's in the x-axis. So it's how long can it go? The longest part before it lands on the floor. For this part of maximum. So for all of these, in the last lesson we had a look at them separately using these parts. So we had found all of these in the last lesson, but right now here I'm going to use another separate way. Well, in fact, I'm going to show something else at the same time. So for this time, what I'm going to use will be, let's take a look at what we have here. What do we have here right now? So we're just going to use some of these. In this part, we have x, we have y. Now we have x and y. How about let's just take, we want to remove the time. Yes, we can remove the time. Well, we're just taking the time from the second part, this x, and sub it into the first part, which is for the y. So that means what we'll get for y will be, so time in this case would be x divided by this whole chunk here. That means what we will get is x. Let's see. So time over this part. Then afterwards, the initial velocity here times sine theta. And then after that, here you also have to sub it into this part behind. So subtract half g, after that, t squared. So t squared, we're just going to use the square of what we had just now. So it'll be x squared, okay, so just the square of this part. Then square of initial velocity, then cosine square. So that's what we will have here. Okay, we've got this part over here. Let's try to make a little bit of simplification. From this part, sine over cosine, you got a tangent. So this part you get a tangent. Then from here you just subtract half g, then x squared, then over initial velocity square, cosine square theta. So that's what you will have here. Well, in this part, we're trying to find those. But how can we continue on from this part here? Wait, did you realize one thing? Here you have x squared, here you have x. How about we try to use the completing square to change it? We try to use completing square. Then, so take everything out from here except this x squared from this part behind. So in front, you will take out negative half, then g, the initial velocity square, then square of cosine. Then after that, then this first term will become an x squared. So the part behind. So everything else that I didn't have, it will just put inside. And wait a second here. This is actually divided by this whole thing. So just to put it simply, you just write it like this. So this part is what you took out. Then from here, you didn't have all those. So let's see what you will need to put in. Of course, it's negative here you need. Then 2. You don't have this g, you have over g. From this part, initial velocity square. But wait, this cosine square, cosine square, cosine. But here you have a tangent. Tangent is sine over cosine. That means you have sine and a cosine here. You have these parts already. After is x. So for this part is what you will get here. So you've got this part. The next part is to move on. So I'm saying that we're using completing square in this case. That means in this part, we'll change it into something square. So when we change it into something square, the first part here, okay, I'm just going to erase this part. X for this x part. Then you have 2 times this whole thing behind. So basically you're just using this part. And beware that this is a negative. Like this, then square. But wait, when you just square like this, you'll get an extra term from here. You get an extra term, you have to cancel out that extra term through different operations afterwards. So at first this is add on, that means you have to subtract. So in this part, you get this initial velocity, power of 4. Since beware that there is this square over here. Sine square, cosine square over g square. And this is the part that you will get. So from here, we can put them in. Well, this first part we didn't actually put it in. We're just leaving it on the outside. But from this part, sine and cosine, at the same time, you could use the double angle formula for sine. It's just that below here you get a 2g. Okay, this is for your first part. Then in the second part, these 2 times together becomes add. This looks a bit complex. So g and g square. First of all, you get a g. Square, power of 4, you get a square. Then, wait, perfectly you put it in this form. So, cosine, they all cancel out. Left is this square of the sine. Then, behind here is the 2. So that's what we got for this part. Then, let's try to draw some conclusions from this part that we got. And just to tell you about this part is actually a locus equation, well, for this projection or this projectile. So this part is a locus equation for that. Okay, so let's see what do we have here. So, well, what if x, wait, here's a square. Can't miss that out here right now. So what if x is equal to this part behind? So when x is equal to this part, that means here you get 0. Then the only part left is here. Y for this part will be this initial velocity square sine square theta over 2g. Now, this looks sort of familiar. Do we have anything about this? Let's check. Wait, this part is the maximum value for y. So actually this part is the maximum value for y, the maximum height for that. Let's check for something else. So we have already used this part. Are there any other parts that we could use? How about in this part? It looks like we could use it together with this y. Let's try that. In this part, so when what if y is actually a 0? If y is a 0, then in this part you do have an actual x here. But how is that right? If y is 0, so it's on this line, which is actually just on the x-axis. When that part is 0, okay, I got it. An extra x, one refers to this at the origin. So one of them just refers to at the origin. So that means we use the other part. The other part will represent here. Wait, so that means we're actually finding the maximum value for x. Okay, so that's what we have. So then it's just tangent theta, subtract this whole thing, except you don't have the square anymore. So, and it means you just have to divide it. You get 2. So tangent and cosine square, you get sine and cosine. But here you also have the initial velocity square, sine, cosine. And then you have to over g. Then after that, from this part, you could use double angle formula for sine. Then you get initial velocity square, sine 2 theta, then you over g. This part also looks quite familiar. Do we know anything about it? Well, yes, we have written it here. It is the maximum value for x. And making a quick comparison is actually the same. Well, just to tell you that if you want to find the time, well, you can just straight away use this part. After you just go and find it. So actually from this part, using the whole thing for our locus equation, we could actually find maximum possible value for x and y. Okay, so that's what we have here in this type of projection or projectile. So far in this lesson, I hope all of you are clear so far. I'm just going to end this lesson here. Okay. And if you like our videos, don't forget to subscribe to our channel. Thank you for your watching.